In this video, we're going to be going through the details in Excel of how we can make graphics that can support our statistical stories. So some of the graphics that we discussed in the lecture are not going to be graphics that we can construct in Excel. What we're going to aim for instead in this video is a basic demonstration of how we can put together some of the graphics and then allow you to explore some on your own for some of the more advanced types. We'll play with what we can, and frankly, I'll just screw around a little bit and see if I can come up with anything interesting, some too. But realize again that Excel is great for basic graphic creation. With some of the more advanced graphics, it's a little bit of a pain. And so that's just part of the nature of the beast. That's not to say you can't put together interesting and very useful graphics in Excel. You absolutely can, but they require some time and some modification that is really beyond the scope of our class. So I really just want to make sure we can get the basics done in here. So in Excel, graphics are located up in the Insert tab. So if I go to Insert, you'll see a little subgroup called Charts. Now I can ask Excel to do specific charts, such as my bar chart or my scatter plot. I can ask it to recommend charts, or I can go to the bottom right and click to see all charts. Now, my Excel automatically pulls up recommended charts, but there's a tab called All Charts that I can look and see what can be done in Excel. Note that we have some familiars, some scatter plots, the histogram, the box and whisker plot, the column, which is Excel's version of a bar chart. We also have some things that you may have seen before, but we didn't talk about, a pie chart or a line graph. And then we have some ones that we didn't talk about, radar plots, surface plots, sunburst, or a funnel plot. These are things that we did not discuss in our class. So again, in Excel, it's not always intuitive how we put these charts together. So sometimes it is, and sometimes it isn't. Let's talk about one that is pretty intuitive. So let's start where we started with the lecture set videos and start with a histogram. I'm going to be focused on the number of polyps that we had after 12 months. So how many polyps on our 12-month follow-up for our participants. I'm going to go up to Charts. I'll click All Charts and go to All Charts. And then I'm going to scroll down to Histogram so that I can insert a histogram. Now, this is not the exact chart that I'm aiming for. It's a histogram. It's only got 3 bars in it, but I'm going to click OK with the understanding that I can always edit something like the number of bars later on. Now, I've got a chart title that I can fill in. I can fill in the X and Y axes here. But my biggest concern about this plot right now is that the histogram only has 3 bars. And as we discussed in the lecture videos, this isn't very descriptive. 1 to 28, 28 to 55, 55 to 82. This just doesn't seem to be very descriptive. Ultimately, it seems to show me that less polyps is more common, which is true, but it doesn't seem extraordinarily descriptive. What I can do is I can go down to the numbers and I can double click on the numbers at the bottom, which will pull up a Format Axis menu. Here, instead of allowing the bins to be created automatically, I can specify bin widths to something that I'm more interested in, or I could specify the number of bins to represent something that is a better listing. So maybe I'll try 20 bins. And I see that I have a lot of decimals involved with my 20 bins, a lot of empty bins. I think in class our small one was 30 bins. And this looks about like what we had in our class example. Instead, maybe I prefer to specify bin widths, and Excel is pretty bad at making readable bin labels here. Can I do it? Absolutely, and we can go check, but perhaps it'd be easier to just specify an easier bin width. Let me specify that each bin I want to be 10 wide. So this goes from 1 to 11, 11 to 21, 21 to 31, etc. And this seems to actually be a pretty good, reasonable, and interpretable chart. All right, so moving on. The next type of plot that we discussed was a bar chart. Now, a bar chart is one that's not necessarily intuitive to put into Excel. For instance, let's say I wanted to do a bar chart based on the treatment. I go to Insert and then I go to Charts. Well, actually, this works out pretty well, so I shouldn't have spoken too soon. Bar chart. Oh, never mind. Column, bar, column, hit OK. Yeah, this doesn't actually work very well. It was the automatic recommendation that works okay. But we'll show how to make those in just a second. My point here is that, again, it's not necessarily intuitive as to how to do this in Excel. What we can do to get this done in Excel is I make what's called a pivot table, and it's a very useful trick for bar charts in Excel. How I make a pivot table is I click in the top left and select all of the data set that I'm going to do, and then go up in the Insert tab to the Pivot Table. I'm going to click on that. It'll say Select a table or range. I've already selected what I want. And then it'll ask if I want to keep it in this same worksheet with everything else here or make a new worksheet, the little plus arrow. I'll let it make a new worksheet for my pivot table. Now, a pivot table is just a way of subdividing the group. So let's say I wanted to count the number of individuals in the treatment or control, or I wanted to count the number of individuals who were male or female. Or maybe, as we saw in our bar charts, I want to find the average number of polyps for male and female. All of these are things that we can construct in our pivot table. Now, also realize we can create multiple pivot tables to investigate multiple of these questions. I'm going to go on and X out of my Format Shape submenu, and I'm going to first assess sex, as we did in the lecture slides. So I'm going to take the sex variable, and I'm going to drag it down, and in this case, I'll have it be a row. I'll put the number of polyps at 12 months in the values, and this will break down the number of polyps at 12 months for the sex values of male and female. Now, first of all, I don't want to start by, and here I can see sum of number of polyps at 12 months. We'll get to that. That is a graph that we looked at, but I'm going to instead do something different. So I'm going to click on the arrow on the right-hand side and click on Value Field Settings. Right now, we are summing together or adding together all of the polyps for males and females. But instead, what we started with in our lecture slides was a count of the number of individuals within each group. So I'm going to count the number of present columns within the males and females. I want to note here that what I'm counting is the present data points, not necessarily the number of individuals. So here, there are 2 missing data points that are currently not being counted. You'll see that there's a total of 20 here, but there's a total of 22 observations. This is because I'm counting how many of the number of 12 polyps group were in male and females. If I wanted to count the number of males and females just overall, I could remove this, click on the arrow, click Remove Field, and drag sex down into the number of values and click Count Sex. So this is going to count the individuals in the male and female group, not the number with present 12-month follow-up data. So clicking on my, in my pivot table here, I'm going to go to the Insert tab, and now I'm going to go to I'm going to go to All Charts, and now I can go to my column bar chart, and this is what I was expecting to see earlier, and again, what the recommended menu in Excel was trying to get me to, is to how to create a column or a bar chart. So I'm going to click OK, and this is how we got the number of females and number of males that we had previously. So this is the entries in our data set. Now let's say I want to update this. That is, I have 9 females and 13 males shown in my bar chart here. But actually, this isn't really representative. I'm going to be looking at data from the number of 12-month follow-up entries. So it doesn't really make sense to use male and female. What I'd do is I'd go and I'd replace this count of sex. I'm going to click on the right arrow, going to click remove field, and now I'm going to replace that with number 12 month. And I'm going to go down to the right arrow, click value field settings, and go to count. This is the number of participants who have 12-month follow-up data. All right, so now let's make another one. I'm going to just copy and paste my, I'm going to select and use Control-C to copy, and then come down here and paste my pivot table so that I can edit it down here to get some different data to make a different plot. Here, if I remember right, the next plot we created was male and female, but instead of broken down by the number of individuals within each, in this case, who had data at the 12-month follow-up, now what I'm going to do is I'm going to look at the average number of polyps within each group. So I'm going to click on that arrow next to it, go to value field settings, and then in value field settings, I'm going to use average to indicate the average number of polyps in each group. You'll see that my pivot table gives me the statistics, and actually this is really handy for descriptive statistics reporting, but also I can again go to insert, go to charts, and then go to my column to select this bar chart. And you'll see here's the bar chart for my new data set, in this case representing the average number of polyps within each group. Now, as we discussed in the lecture videos, sometimes the scale of the y-axis can be deceptive, and it is almost never a good idea to stick with the default created. Either use something that's meaningful theoretically, theoretically, that is practically significant or clinically significant, or center at a statistical value, say the minimum possible, which would be, in this case, 0. To do this, I'm going to double-click on my y-axis to open up a Format Axis menu in Excel, and then go to Minimum and replace the minimum with 0. So I'm going to highlight it and type 0, and I'm going to hit the Enter key. You'll see that my plot automatically updates to reflect the new y-axis scale. And this is how we got that third plot in our lecture slides, where we demonstrated the difference that the axis can have on the interpretation of the plot. This doesn't look nearly as large of a gap as the previous plot did. All right, now I'm going to copy and paste again so I can make yet another graph with my pivot table. Over here, let's see, what was the next graphic we did? I think the next graphic we did was the sum of the number of polyps. So I'm going to click on that right arrow, go to Value Field Settings, and then find sum, the sum of the polyps. Now here I have the sum in the of the number of polyps at 12-month follow-up for females and males. And again, I'm just going to do the same process. Insert, charts, go to column for my bar chart, and then click on my option, and then hit OK. And now I have a bar chart for the number of polyps within each group, which again, depending on the research question, may or may not be actually useful. I'm going to copy and paste one more time. Now, I think one of the next plots that we looked at is breaking down the average polyps by not just male and female, but by treatment and control within that. To do this, we add not another row, but a column. So I'm going to go into my pivot table options. I'm going to select treatment and click and drag it down to column. You'll see that now I have a breakdown with columns. I have the placebo and the drug, and rows, male and female. Reading this table, an entry in the table represents an individual who falls within both the row and the column. In this case, 8 represents 8 females got the drug, or excuse me, there were 8 polyps within females who got the drug. 81 represents there were 81 polyps within males who got the drug. 194 indicates 194 polyps in males who got the placebo, and 198 indicates 198 polyps in females who got the placebo. Right now, all of these are listed as the sum of the number of polyps, which is not what I'm particularly interested in. What I'd rather have is the average of the number of polyps. So here I have the breakdown of the average number of polyps. So for females with the placebo, on average, they had 49.5 polyps. On females with the drug, on average, they had 2 polyps. On males with the placebo, on average, they had 27.7 polyps. On males with the drug, they had on average 16.2 polyps. Now I can go on and graph this by going up to Insert, going down to Charts, and then selecting my clustered column chart. Again, that's our bar chart, and selecting OK. Scrolling over, I have my chart here, and I can see, again, the breakdown from male and female by placebo versus drug. So here for females, the drug was very effective, or seemingly very effective, and for males, the drug was seemingly effective. Now recall that we had an example in class where we switched these so that we could compare better. Again, this is comparing good for comparing placebo to drug within the context of female and male. I can compare female to male within the context of placebo and drug by clicking and switching the axes. So right now I have the columns listed as treatment and the rows listed as sex. Now I'm going to drag sex up to the columns and drag treatment down to the rows. And you can see I've switched my axes in the plot. Now my axes are the placebo and the drug, and my colors are female and male. And I can see, again, females did worse than males in the placebo, but females are doing much better than males in the drug group. So I can switch those axes up. All right, well, now let's jump into creating some histograms. I'm going to go back to my original sheet. And so to make or not a histogram, excuse me, a box and whisker plot. So to make a basic box and whisker plot, I'm going to highlight the column I'm interested in, go to Insert, go to All My Charts, and then scroll down to the box and whisker plot. Here you can see I can create a basic box and whisker plot for this variable, that is the number of polyps at 12 months. Now we can create the subdivided box and whisker plots, or basic ones anyway, by selecting a column as well as its column of categorical variables next to a column of continuous variables. Or if we want to, I can select the column of categorical variables, hold Control on my keyboard, and then select the column of continuous values that I want to match with it. I'll go to Insert, then Charts, All Charts, Box and Whisker Plots, then hit OK. And this is how I create a box and whisker plot comparing a drug to placebo based on the treatment and treatment control column and the number of polyps at 12 months. Again, to select the data, selected the first column I was interested in, held the Control key, and then selected the column with the continuous values in it. Now I can make paired box and whisker plots, but in Excel that's a bit difficult. Ultimately, what I would have to do is I would have to have different entries in different columns for the second grouping. So this would actually work in this case. Let's say I wanted number of polyps at 3 months versus number 12 months. I think this is what we did in class. And then the treatment, I could highlight all 3 of these. And then what Excel can do is it can make one distinction based on the categorical variable and then one distinction based on the columns. To do this, I'll highlight these, go up to Insert, go over to Charts, click All Charts, and then go down to Box and Whisker Plot and hit OK. And you can see now that I have the treatment and control broken up by the number at 3 months versus the number at 12 months. This is handy, but is not as handy as it could be with, say, if I wanted to do this breakdown by male and female. This could be kind of a pain to have to put together. So it's nice when it's available, but unfortunately it's not necessarily always available. On the other hand, if you think about this, well, anyway, it's not always available. Okay. And it is always available. It's just that the data format is kind of yucky for it sometimes. All right, the last thing that we had, I think, is the scatter plot. So scatter plot, again, we have two continuous variables that we're looking for the relationship between. So I'll highlight the two columns of interest with my continuous variables. I'll go up to Insert, go to Charts, and then I'll go to All Charts and scroll on down to XY Scatter. And I'm going to go on and select the, so this one, no, that's not at all what we're looking for. I'm going to select this second chart, this basic chart with the representation of the number of polyps at 3 months on the x-axis and number of polyps at 12 months on the y-axis. This chart, if you see, puts number at 3 months and number at 12 months on an axis, but this goes in order of the number of entries. So we have the first data point horizontally. I can't show you here. The second data point, the third data point. This might be the 4th or the 8th, the 9th, the 10th, the 11th, the 12th, which isn't particularly interesting. We want these to be graphed by each other. So looking at this, I can quickly double check. I would expect an entry of 67 units in X and 63 units in Y. So if I go over 67 units in X and 63 units in Y, yes, I do see this on here. This is, in fact, the graph that I think it is, and this is my scatter plot created using Excel for the number of polyps at 3 months versus the number of polyps at 12 months. Unfortunately, though we can create the scatter plot with multiple colors in Excel, that is actually kind of a pain to do. So I encourage you to Google around about that if you're interested in finding that out. But that is not as straightforward as it seems like it should be. It feels like we should just be able to select the additional column and then have it do colors based on that. At least in my experience, I haven't found a way to do that. Y'all, there's a ton about Excel and graphics in general. They are massive, massive, massive fields, and I am by no means the be-all, end-all expert and the sole keeper of knowledge regarding graphics in Excel. So feel free to play around with it. There may be some individuals you find who have really good ideas or really clever ideas of how to put this together. But I hope this video has been helpful in terms of making some basic graphics using Excel in the different types of graphics we discussed, the different families. We had histograms, we had bar charts, we had box and whisker plots, and we had scatter plots.